Hi everyone, welcome to today's episode of CooTube. Today we're going to be talking about how to solve literal equations. Today's goal is to apply what you know about solving equations in order to rewrite equations in the form of a given variable. Before we begin today, you want to make sure that you have the materials ready for this lesson. If you have not already done so, please print out a copy of today's notes. If you don't have access to a printer, you can always just use a piece of scrap paper, but make sure that today's date's on top and literal equations is written on the top of your lined paper. For today's notes, you definitely want to make sure that you have a pencil out, and a colored pen is great for when you are doing corrections today. All right, so let's get started. So literal equations, literally, what is it? A literal equation is an equation with more than one variable. So in other words, think about those formulas that you might have kind of talked about in geometry class last year or years before. All right, and when we're talking about literal equations, the unknown values are represented by variables. In order to solve a literal equation, we must apply our properties in math and solve algebraically in order to isolate the variable. All right, so that's today's goal, is to still isolate a variable, but it's going to be a given variable. So as you see here in this example on the bottom, we have the formula for circumference, which equals 2 pi r, and in this case, they're asking us to isolate the variable r. All right, and what we do to solve for r is to apply the properties of math and use inverse operations on each side of the equation. So let's get started with our first example. All right, you don't need to write this down in your notes. If you have the copy of the guided notes printed, you're going to see that this is on top. But what I want to do is I want to start with the example on the left. We're taking an example that should be really familiar to us. 2x plus 5 equals 11. If I ask you to solve for x here, what would you do first? That's correct. You'd get rid of that constant. You'd subtract 5 on both sides of the equation. And you'd be left with 2x equals 6. To solve for x, we would get rid of our coefficient of 2 by dividing both sides by 2. And then finally, we'd be left with the solution of x equals 3. So hopefully this example to the left looks really familiar to you. And you're going to see our goal here was to isolate x. But if I took our skills from solving a normal equation to now solving a literal equation, notice my example to the right. Solve ax plus b equals c for x. In your guided notes, I would recommend writing this example down. Now in this problem, we're asking to find x. Notice that this is very similar to the first example we did. Instead of 2, we have a. Instead of the number 5, we have b. And instead of the number 11, we have c. To solve for x, we're going to do the same thing. We're going to get rid of our constant here of b. So what I do is subtract b on both sides. And you can use that practice problem on the left as a reference point. From here, we're going to bring down, starting from the left, ax equals, we can write c minus b, but I know intuitively that when we write expressions properly, the variables come in order alphabetically. So I'm going to write negative b plus c. I'm going to push you as a student today to really try to practice writing it in proper form. Now my x is still not isolated, and the only thing that's standing in the way is that variable a. In this case, we're going to use that a as a coefficient. To solve for x, we're going to divide both sides by a. What I do to one side, I have to do the entire other side. These a's cancel out. I'm left with x is equal to negative b plus c all over a, and that's going to be my final answer. For those of us that are ready, we can also write it in another way. Now we know that denominator of a belongs to both numerators, okay? So another way that we can actually express that is to actually split it up into two different fractions. X could also equal negative b over a plus c over a. All right, and both of these answers are correct. All right, so let's take some time now and apply our new skills of solving literal equations. If you need to pause the video to write down these two examples, you can, but I do want to ask you, once you finish writing them down, please come back and unpause the video so you can actually watch as I go over it. All right, in class example number 1, we're going to see the literal equation 2x minus 2y equals 5, and they're asking us to solve for the variable y. So the first thing I'm going to do is I'm going to take a look at this problem. If I need to, I'm going to underline or bold or highlight the variable y, and I'm going to ask myself, what do I want to get rid of first? All right, and if you need to, this is totally optional, but thinking back to a simpler example, right? If I made this a number, 10 minus 2y equals 5, ask yourself what would you do first, right? We'd get rid of that constant of 10. So I'm going to do the same idea here, except we don't have a constant of 10. We have our constant of 2x. So I'm going to get rid of that entire term, 2x. And the way we do that is to apply our inverse operations. I'm going to subtract 2x on both sides of that equation. Oops, sorry about that. So what I do to one side, I do the other. Now we're going to start from the left and go to the right. I'm going to bring down my negative 2y is equal to, I can write 5 minus 2x, but remember I'm going to try my best to write it in proper form. Negative 2x plus 5, applying that commutative property of addition. Now my y, unfortunately, is still not isolated, right? That was our goal, to solve for y. So the last step is to divide both sides by that coefficient of negative 2. So I'm going to show my work by dividing my left side and dividing the entire right side by negative 2. Now when I write my final answer, y equals negative 2x plus 5 all over negative 2, I need to take the time to see if I can simplify this further. Now remember, that denominator, I'm going to highlight that in orange. This denominator of negative 2 belongs to both numerators, okay? Both terms of my numerator. So I need to double check if I can simplify this. All right, and this step in green is going to be optional, but I'm going to take the time and actually write negative 2x over negative 2 plus 5 over negative 2. And we're going to see if we can simplify anything. We can. We notice that we can simplify that first term. In this case, this first term simplifies to, well, negative 2 divided by negative 2 is positive 1. So I'm going to write, I'm going to write y equals x. I'm going to change those signs, x minus 5 over 2. And that's my final answer in simplest form. So it's important we take that extra step and see if we can simplify our term even further. All right, let's try number 2 together. So number 2, we have a very similar problem. We're solving for y again, all right? And they're saying the literal equation is 2x minus 4y equals negative 12. All right, so let's take a look at how we'd solve this problem. So the first thing we do is to get rid of my constant, or my first term of 2x. So I'm going to subtract both sides by negative 2x. I'm going to start from the left and go to the right. What do you think I should bring down? That's correct. Negative 4y is equal to negative 2x minus 12. Then I'm going to ask you, what should I do next to isolate that variable y? Remember, our goal is to get this y by itself. Good. I have to divide both sides by my coefficient of negative 4. So what I do to one side, I have to do the entire other side. All right, and now I'm left with y is equal to negative 2x minus 12 all over negative 4. But I'm going to ask myself, can I simplify this any further? All right, I'm going to erase this answer here for just a moment. All right, And when I take a look at that, remember this step in green is totally optional. I can take that negative 4 and put it with both numerators. Minus 12 over negative 4. And we're going to see if we can simplify each of these terms. So my final answer, y is equal to, I'm going to pay attention to this first term. Can I simplify negative 2x over negative 4? Yeah, right? That becomes x over 2 minus 12 over negative 4. So now I'm looking at that second term. Well, 12 over negative 4 is negative 3. So I'm going to write minus negative 3, in other words, plus 3. All right, so I can leave my answer like that. If you really want to get fancy, we can pull out that coefficient. Remember, x over 2 is the same thing as saying 1/2 x. All right, my coefficient here to x is actually 1/2. So another way that we can write this is y is equal to 1/2 x plus 3. So I would accept either of these solutions for number 2. All right, hopefully these are getting a little easier. We're going to do 2 more class examples, and then you're going to have an opportunity to try some on your own. So in example 3 and 4, we have 2 more literal equations. If you need to pause the video to write this down in your notes, you may do so. And then when you unpause it, we'll go over each of these examples. All right, in number 3, we have a is equal to 2 times the quantity L plus W, and they're asking us to solve for L. Now I'm going to ask myself, what makes this problem pretty difficult? Well, we notice that L's inside a set of parentheses, so we kind of have to brainstorm as to what we can do here. Now, If your gut instinct is to distribute, we could totally do that first, all right? So let's say our plan is to distribute that 2. So I'm going to start with A is equal to 2L. Notice I'm using a cursive L for L, so it doesn't look like the number 1, plus 2W. Now, if I'm solving for L here, how would I go ahead and isolate that variable? That's correct. I'd get rid of the 2W, so I'm going to subtract 2W from both sides. I'm going to start from the left and go to the right. We have A minus 2W equals 2L. Now my goal is still to isolate that L. How would I get that L by itself? It's correct. I divide both sides by 2. And I always write L is equal, whatever variable I'm solving for first has to go in my beginning of my solution. L is equal to A minus 2W all over 2. Remember, we need to take that time and actually double check to see if our answer can be simplified any further. So what's in green is optional, but if you need to write it out in 2 separate steps, right, that denominator 2 belongs to both numerators, and we get the final answer of L equals A over 2 minus, this cancels out, the 2 over 2 cancels out to 1, so we have that final answer. All right. Now, although this was a great strategy to solve this, there was actually another way that we can go about solving this. So what I'm going to do right now is I'm actually going to go over how we can solve that exact same equation. I'm going to write that on top here, A equals 2 times the quantity L plus W for L, and see if there is another way of solving it. And this is where using those properties of math is really going to come into play here. Well, personally, I look at this equation and I don't want to distribute first. All right, so I asked myself, well, if I just want to get rid of my coefficient of 2, right, that 2 is getting multiplied to that entire expression, I can essentially multiply both sides by 2. And now I'm left with A over 2, sorry about my stylus pen, is equal to, these 2's cancel out and I'm left with L plus W. Now in order to solve for L, I'm going to subtract W on both sides. I apologize, I'm bleeding into number 4 a little bit, so just kind of ignore that. And I'm going to be left with the answer, L is equal to A over 2 minus W. And you're going to notice that we get the same answer either way. So I really challenge you today to really push your thinking and try to apply a few different strategies when solving some of these problems. All right. So I'm actually going to skip number 4, and I'm going to ask you guys to now try 3 examples on your own. So if you need to, pause the video, write down number 5, 6, and 7. Try these out on your own, and then when you're ready, unpause the video and we'll go over all 3 examples together. All right, so hopefully you finished number 5, 6, and 7. We're going to go over each of these examples, and like TV magic, here's the solutions, all right? So I'm going to kind of go through each of these steps here because there's some really good things to kind of notice as we're kind of going through our solutions. All right, the first thing in number 5 is you're going to notice I multiply both sides by the reciprocal of 1/3, which is 3. In other words, I'm clearing both sides of the equation, right? So we get 3v is equal to pi r squared. So hopefully you have that in your notes. From there, to isolate r, I want to get rid of my coefficient of pi. Remember, pi looks like a variable. We can almost treat it like a variable. Pi actually has a value, so it's a coefficient here. So I divide both sides by pi. I'm left with r squared is equal to 3v over pi. And in order to solve that, the inverse of squaring a number is the square root. So my final answer should be r is equal to the square root of 3v all over pi. If you got that correct, you can use your colored pen and put a little check next to it. If you got it wrong, you might want to pause the video and try to find your error. All right, number 6 and number 7 were very similar. I gave you the exact same literal equation, but I'm asking you to solve for a different variable here. So let's kind of go through how to solve that. In number 6, I'm asking you to solve for the variable b here. And this is not too bad, right? In order to solve for b, well, I need to clear out that c first. So you're going to notice I first multiplied both sides of the equation by c. We're left with cv is equal to ab. Then to solve for b, I divided both sides by my coefficient of a, right? And we get our final answer of b is equal to cv over a. Once again, double check your work. See if your answer is written properly. The variable you're solving for is first. you kept every variable the way it was written in the original problem. So the capital V, the lowercase c, the lowercase a. If you got that correct, put a check next to it. All right, in number 7, you're going to notice we have the exact same literal equation, but now I'm asking you to solve for c. And what was difficult about this for some students might have been the fact that c was in our denominator. Now we could actually start we can start number 7 the exact same way we started number 6. We're not used to moving the variable we want to solve for, but essentially if we moved the c over to the left, it gets us closer to isolating my variable c. So if I multiply both sides by c, we're left with cv is equal to ab. Then to solve for c, remember this is when we want to isolate it, we're going to treat v as my coefficient. So I'm going to divide both sides by v, and you're left with the final solution of c equals ab over v. This was a little bit more challenging. If you got that correct, put a little check next to it. If you didn't, mark it wrong and try to find your error. All right, so let's keep moving. The last 3 examples we have are going to be a little bit more challenging. So I posted these 3 examples because I want us to make sure that we don't fall in some traps. Sometimes you may have to use factoring, and that's a really old skill, okay, to isolate a variable if it occurs in more than one place. So I'm going to talk to you about what this means a little bit. In example A, we're going to do this one together, and then I'm going to ask you to do B and C on your own. So if you need to take a moment to actually pause the video to write down all 3 examples, you can, but I'm going to go through example A right now. All right, in example A, we have 2x plus kx equals m for the value of x. All right, and this might be the first time when we're really dealing with solving for a variable when there's so many different variables going on in an equation. All right, and that's the challenge of a literal equation. But if I take a look here, what's frustrating about this problem is that x shows up in more than one term. But remember, if it occurs in more than one place, we can apply factoring. And I'm going to kind of remind us what factoring is. Well, I take a look here. These 2 are like terms, but I can't do anything with those coefficients. 2 plus k, there's nothing I can do there. So what I'm going to do is to factor out my GCF, which in this case is x. So I'm left with x times the quantity 2 plus k is equal to m. Right? I can pull out that common factor of x. Now to solve for x, I want to get rid of this entire expression, the 2 plus k. So to do that, I'm going to divide both sides by 2 plus k. What I do to one side, I do to the other side. You don't need the parentheses there, but I know some students like to kind of group that together, right? Because there's multiplication going on between x and the quantity 2 plus k, so I can divide both sides by that 2 plus k, and I'm left with x is equal to m over, and I'm going to write it in proper form, k plus 2. And that's it. So I want you to take what we've learned about factoring, right? Pulling out that GCF and seeing if you can kind of use that to get to the solutions for B and for C. So go ahead and pause the video. Try these 2 challenge problems on your own. I would call these 2-star problems. These are definitely a little bit more challenging. And when you're ready, you can unpause the video to check your answers. All right, so hopefully you've had a chance to try B and C. Let's kind of move on like TV magic. Here are the solutions. So I have the solutions written here. I'm not going to go through each of these formally, but if you need to, you can pause the video and take a look through my steps and kind of look how I've isolated certain variables and how I've used factoring here to get to my solution. These were 2 challenge problems, so take a look at the solutions and my steps here. All right, thank you so much for watching this video on solving literal equations. Don't forget to like and subscribe.